So far, while designing this model, we have not taken into account data types. So say, for example, the designer of this component knows that we're going to implement this component on a 16-bit fixed point processor. Since we can automatically generate code from this model, we might as well design the data types for this component in the Simulink model itself. And Simulink allows you to do this. So as a designer of this subsystem, I know that I want to implement this on a 16-bit processor. And so I'm going to have to fix both the input and the output interfaces to use 16-bit data types. Let's see how this is possible. I can double click on the input block and select the signal attributes tab. Previously we'd set the sample time, but we can also set the data type. So instead of Simulink inheriting the data type, let's specify the data type. So I'm saying specify the data type to be of type fixed point. But I'm also going to use Simulink's data type assistant to decide the fraction length for the best precision. So I know this signal has a minimum value of -10 and a maximum value of +10, and I can use calculate best precision, and Simulink's data type assistant says that it needs 5 bits to capture the integer value between -10 and 10, and the remaining 11 bits can be used to store the fractional value. I can say OK. At this point, let me turn on the port data types. So as you can see, the input has been fixed to have a 16-bit fixed point value. But I also need to fix the outputs. One way to do this, of course, is to double click on each block and set the data types there. But what I'm going to do is set it using the Model Explorer. I'm going to click on this block to bring up the Model Explorer. The Model Explorer is a different view into all open Simulink models and the Simulink workspace. The left pane here shows the model hierarchy. The middle pane shows details of the model or selected block. And the right pane shows the parameter dialog box for the model or the block. So I can select this, and you can see it shows me the parameters dialog box on the right pane. So you can see here that the output data types for outputs 1, 2, and 3 are set to inherit auto, but I'm going to set it to fixed point data types based on my specification. Let me close the Model Explorer and look at this now. Let's try to run this component. As you can see, Simulink has thrown an error. It says data type mismatch. The input 1 expects a signal of fixed point 16-bit, whereas it's being driven by a signal of fixed point 32-bit. Let's look at the signals here. You can see that the input is a 16-bit fixed point number, whereas the output from the gain is being converted by Simulink to a 32-bit fixed point number to prevent overflows. At this point, I can force Simulink to keep the value data type of the signal the same instead of upgrading it automatically. Double click on this, select the signal attributes, and instead of inherit via internal rule, I'm going to select inherit via backpropagation and select apply. Now let me update this diagram, and you can see that all signals are now 16-bit fixed point, and we should be able to generate C code from this for implementation on a 16-bit processor. So let me save this model, simulate it to ensure that it runs fine, close it, and come back to the main model. Now let me try to run this main model. As you can see, Simulink is again warning you about a data type mismatch. So let's look at another way of fixing this. So we have to find some way of converting the output of the integrator from a double to a 16-bit fixed point value. I'm going to go to the signal attributes library and select the data conversion block. And I'm going to drop this block on my signal. Now let's try to run this model and look at the simulation outputs. Double click the scope and you can see that the outputs are similar to the outputs of the subsystem, except with different TS1 and TS2 values, since these are now defined in the MATLAB workspace. So through this example, we've seen how Simulink allows you to specify as little or as much as the data types, and how Simulink can catch some of the errors that might creep into the modeling process because different component engineers have specified the interfaces differently.